Good morning, everyone. Welcome to ArcGIS Pro SDK for .NET, Understanding Feature Services, a guide for developers. This is High Energy Charlie McLeod, and I am Russell Brennan. Here's our agenda for today. We're going to start with a feature service overview. We're going to get into just some general info about feature services. We're going to talk about branch versioning, editing feature services, and then we're going to follow up with some special considerations. So what is a feature service? It's the platform information model for feature access. This means the ability to get access to your row data, whether it be in a table or a feature layer, as well as the geometry of those rows. This is unlike some of our other service types that return either images or dataset types that are very lightly attributed. With feature services, you get access to the full information. It's also the ability to access your data through our platform. So whether you're accessing through web browsers, desktop applications, or mobile applications, that's how, through feature services, you can get access to your data. It's also the sole entry point for performing edits against branch version data. This is our new versioning model built for feature services that we'll get into much deeper later in the session. They're also where we've been focusing a lot of our efforts on some of our distributed data workflows, so taking your data offline into the field when you don't have connectivity, doing edits, and then syncing back to your back-end data store. It's also the entry point for the platform adoption of utility networks and our upcoming parcel fabrics, allowing multi-user access to these dataset types. In the future, we'll likely have other dataset types that are feature service based as well. So a feature service specifically, it can have layers or tables. Layers simply have a shaped column and tables do not. Both are supported through the feature service. It allows querying, analysis, and editing of the data. Everything done through the feature service is done in a RESTful way, relying on REST requests and responses to the server. If you're in the plenary, you would have heard about web layers or web feature layers. I'm going to be using web layer, feature layer interchangeably with feature service throughout the session. Feature service was kind of what we started with ArcGIS Server. As our platform has evolved, when you're talking in the platform information model, it's often referred to as web layers or web feature layers. I'm probably going to use mostly feature service throughout this session. So within a web layer or a feature service, you can have one or many sub-layers. So data supported in feature services includes all of the items I've listed here. We can have points, lines, polygons. You can have relationship classes between your tables and layers. You can have attachments. You can have domains on your fields. All of that is supported through all feature service types. Some feature services support more complex data, such as utility networks or our upcoming parcel fabric. So feature services aren't just about the back-end data. When you publish and create your feature services, you also get other properties of the layers when you publish them. So you get things like I've listed here. You get renderers, you get editing templates, you get field visibility. If you have definition queries applied to your layers when you publish, those will be honored in the feature service as well. So this is stuff you just get for free when you publish feature services. And it's unlike what you would see with, for example, a file geodatabase or an enterprise geodatabase where you just get the data. So the feature service is accessed through our REST API. Within the REST API, we have operations and we have resources that are used to perform actions and to obtain information about the data. These operations can either be at the service level or they can be down at the layer level as well. So examples of operations are things like query, apply edits, calculate. Those are operations that perform actions. And then we also have resources, which you can go to get information about the particular resource. So the layer resource or the service resource will give you information about, for example, the spatial reference or the extent or that sort of thing. And it's through these operations and resources that Pro interacts with the server via REST requests. So far I've just talked about what a feature service is. I wanted to take a quick moment just to talk about how you can create them. You can publish them from maps in Pro or ArcMap. You can use REST, the REST API directly to upload service definition files. You can use the Python API to create web layers. And then through the portal user experience, there's a number of different ways that you can create your feature layers, your feature services as well. So when working with feature services in Pro, your data and layers should behave just like any other geodatabase data source. This is mostly true, but we wouldn't be having this session if that were entirely true. So you as developers are mostly going to write code as though the feature service were any other data store, the main difference being how you connect to the data. Feature services in Pro through the SDK are going to support the same types of objects that you would expect to get from other geodatabase-like data sources. Charlie?
Okay. So within the API, probably the primary method of creating a layer from a feature service will be through Layer Factory and its create layer overloads. Simply provide the service URI to the feature service, and you will get back one of two things. If you provide a service URI that points to the feature service itself, you're going to get back a group layer. And then within that group layer, you will have child feature layers added for each individual layer defined on that service. If there are any non-spatial tables defined on that feature service, they're going to be added to the standalone table collection at the bottom of the TOC. If your service URI contains a specific endpoint, a layer ID on the end, then you're going to get back just that individual feature layer. If you want to add a non-spatial table directly, then you're going to use standalone table factory create table for that purpose. All right, so an example then, I've got three service URIs. I've got on the top, I've got a hosted, then I've got a by reference. And then the last one's kind of interesting. It's actually a URI to a portal item. With the portal item, when you make the layer factory call, that portal has to be your currently active portal, or you'll get an exception when you call layer factory. All right, so on each three calls to create layer with each of those URIs, it's going to return back to me a group layer. The only difference syntactically about the bottom one is I'm specifying that it be added to the top, you know, with that index, that 0 at the end there. You can also access feature services through the ArcGIS.core.data API. So in this case, I have, once again, my service URI. Now I'm creating something called a service connection properties. Into that service connection properties, I pass the URI, and then that becomes the argument to my geodatabase call right here. This will return to me my feature service data store, and then from that feature service data store, I'm enumerating each of the data sets, and I'm adding them to my map using this particular overload, create feature layer, and I pass to it as the argument each individual feature class. And I'm going to show you examples of each of these. All right, so Pro. Nothing special about this particular project. I have here on this feature service tab a series of demos, and I'll work through them from left to right throughout the session. Here's the first one, something called Create Layer Options. Okay, so in this code, I have defined a series of service URIs, basically in the same order that I showed on that first slide. I have a hosted, I have a by reference, and then I have a portal item. Excuse me. I retrieve the active map, and here are my individual create layer calls. So I create the layer, it returns to me a group layer, and so on and so forth. Let's just run it out. Into the TOC, there come my individual feature service layers. Notice I get a group layer for each, and if I expand the group layer, it contains individual feature layers for each of the individual endpoints defined on that service. Okay, let's try this one. Create layer options 2. Okay. Here in this particular instance, I have service URIs. Notice I have a layer ID specified directly. So in this particular case, when I do the create layer call, I'm going to get back just that individual feature layer, and you notice this feature layer cast. Okay, and my feature layer. Here I'm just using that other overload create feature layer. It does the same thing. It just allows me to avoid using that cast. It provides back a feature layer directly. Note the difference now in my TOC is that I don't have a group layer. I just have the individual feature layers that I created directly. Okay, one more. This time, create layer via GDB. So once again, my service URIs, you've seen those. I have them in a loop here. Notice that for each one, I'm going to create a service connection properties. I'm going to pass that service connection properties as the argument to my geodatabase call, and that will return to me an instance of the underlying feature service data store. Once I have that feature service data store, I'm going to enumerate it for its individual feature classes, and then I'm going to pass each feature class as an argument to that layer factory create feature layer call. I'm adding each feature layer to a group layer that I'm just making by hand. So essentially I'm going to recreate that same table of contents I get sort of for free, if you will, using the layer factory create layer. If I have any non-spatial tables in the feature service data store, I'm going to enumerate those too, and then I will add them to the map using standalone table factory create standalone table. Let's just run the code out. And into my table of contents come those group layers I'm sort of making by hand. Within each are the individual feature layers that I created using the feature classes that I'd extracted from the feature service data store. One of those services actually had a standalone table. You can see it's been added to that standalone table collection. So Russell mentioned that once you sort of have a feature layer on top of a feature service, for the most part, it behaves pretty much like any other feature layer sourced on file geodatabase or enterprise. So here are a couple of other demos to illustrate that. The first one, select features. Let's take a look at what that does. Okay, in select features, I'm extracting the feature layers from the first group layer. That's what I'm doing here. I'm creating a spatial query filter, and I'm going to select all features in those layers that are contained within the current map extent. So there's my filter geometry, my spatial relationship. Okay, I'm going to do the select here, and then I will enumerate whatever I have selected in this return row cursor. So this is just pretty much vanilla ArcGIS.core.data code here. Okay, I perform the selection on the first layer, nothing is selected. I perform the selection on the second layer. This time I have 65 features selected. I enumerate them through the row cursor, retrieve the features in the normal way. So there's nothing special about the feature layer on top of the feature service. It behaves pretty much the same as any other feature layer would. Let's just run this out in this particular scenario. And there are my selected features. On this one, change renderer. Let's see what that does. In this particular case, I'm getting the layer called buildings hosted from the group layer buildings hosted. I'm going to change its renderer. It's currently got a simple renderer. I'm just going to change its renderer to be a unique value renderer defined on the field height. And there we see on the fly, I just changed its renderer to a unique value renderer. So pretty much the same as I could do with any feature layer.
All right. Okay, so moving into a little bit more general feature service info. I wanted to start here with a general feature service architecture diagram. So the top 3 boxes in this diagram are meant to represent Pro and its components. Within the top group, the very top box is the application tier, the middle box is the geodatabase tier, and then the bottom is the feature service client tier. The items in this top group communicate with the items in the bottom group via REST. And the bottom box shows the server, whether it be enterprise, online, or standalone server. Within this bottom group, we have the feature service, and then it communicates with whatever the backend data storage happens to be. From a developer perspective, you can look at the Pro application tier, and this is where you'd access things like editing, mapping, geoprocessing modules. The geodatabase, you can look at you would think of it as the ArcGIS core.data module. And then the feature service client, this is something that's really just an internal thing. There's no Pro SDK for that. You work with the top options, and then it just works. On the bottom box, you have the feature service that you communicate via REST, and it also has internal communication back to the data storage. So you can think of the client in Pro as just sort of a translator that translates calls from the upper parts of the stack so that you don't need to worry about it, and makes those REST requests back to the feature service. So I have some examples here. Most of these examples are sort of core data specific. So if you're using search cursors, this is going to map to a feature service query request. If you're doing insert or update cursors, this is going to map to a feature service apply edits, and so on. We're doing a lot of translation to make it just work in Pro through the Pro APIs and through the Pro application. So now into some of the technical details for consuming these services in Pro. So feature services have a layer, have layers or sublayers that have IDs and have names. These names are typically based off of the layers in the map that you publish. And there's some peculiarities when we run into these as a data source. Those layers that are in your map, they can have any type of name. They could have special characters. They could be duplicates. But those don't really work well within a data source. We need uniqueness within the data source. And we can't have invalid identifiers if we're doing things like SQL parsing, which we do a lot of client side. So we needed to come up with a naming convention that was going to work within the data store client side, and we came up with this layer name that is L for layer, followed by the layer ID to make it unique, and then followed by a cleaned up name that allows it to be SQL parsed. So this gives us unique feature class names within the data store. And you may run into this when asking, for example, for the feature class name. So I have this example here on the left where I've published a service that has 4 layers. We have 2 layers that are both named parcels, and then 2 layers that just have complete sort of random characters for names. And when we clean those up in the data store, it becomes L0 parcels, L1 parcels, and then the other one would be a L2 all underscores, L3 all underscores. So a little bit of functionality that is unique to feature services in Pro. We have some local caching that we do. This is done to improve performance. And what we do here is take a local copy of your data. We use this for both querying and editing. So as you're panning and zooming around the map, we will keep a local cache of your data and use that to improve performance. We also use pagination. So as you make query requests for records from the server, you will typically be limited to a few thousand features at a time, and you can ask for pages and pages of data. Internally, the Pro client takes care of pagination itself. So for you as developers, this will make cursors appear continuous. You'll just ask for the next row. We'll go ahead and fetch the next page. You guys don't need to worry about doing that. So there's a few options you should be aware of with respect to how your data is stored when working with feature services. The first option I want to talk about is hosted. And so this is where when you publish your data, the data gets copied to the server and is hosted on the server. So the connection between your local data and the server is broken. It's all accessed through the server, and it's all hosted and copied onto the server. With hosted data, we support all of the things you'd expect as far as data set types. We support tables, feature classes, relationships, all the things I mentioned a few slides ago. With hosted feature services, the editing transactions in Pro are always going to be short transactions, meaning that there's no concept of undo, redo, or saving and discarding edit sessions with hosted data. The other data storage option is to use data in your enterprise geodatabase. This is referred to as by reference because your data is referenced in your existing enterprise geodatabase. We do not copy the data from your enterprise geodatabase to the server. It remains in place in your server. By reference services support the same things that hosted services support, but they have expanded beyond the traditional data set types to support some more complex data sets. I've already mentioned a couple times utility networks and parcel fabrics. There's also annotation, dimensions, true curves, attribute rules, and a few others. Editing with by reference services can either be short transactions like with hosted or long transactions when used with branch versioning, which we'll get into shortly. In this case, of course, your data is going to remain in your enterprise geodatabase, so it's up to you to manage your data. Your data management will be done at the back end enterprise geodatabase. You won't be going through the portal to manage your data.
I'm up.
Yep. Charlie?
All right, back to Pro. Let's add some layers back into our table of contents. And we're going to take a look at some of their underlying information. So same as before, different set of feature services, create layer on the layer factory. You guys have already seen this before. We add our layers into the table of contents, and I've got 3 or 4 different types. Let's execute this demo I've called query info. Okay, so I'm just going to enumerate all of the feature layers that I currently have in my table of contents, and I'm also going to extract any standalone tables that I have in my table of contents as well. Then for each layer, let's first get its layer name. The layer name by default will be the same name that you used when you originally published the service, barring any changes that were required to add to it. The dataset. So the dataset name is going to be that original layer name, cleaned up as needed to support SQL, and then prefixed with L, and then the corresponding layer ID. We'll get the connection string from the layer. That's in this data connection, workspace connection string, that's my URL. And then in the data set of that connection is actually that layer ID. So on a regular feature layer, shall we say, that data set would actually be the name of the underlying feature class. So we would expect this particular layer to be L0 and then whatever the cleaned up layer name is that was used on the feature class. Okay, so I enumerate all of my layers, and then I basically do the same for any tables in my standalone table collection. Okay. All right, so I've just popped up that information in this dialog. Let's take a look. So corresponding first to the first layer we see in the table of contents, buildings branch, there's that original layer name. I haven't changed it. Notice it didn't need any cleanup, so it's remained the same. And there's that L prefix with the layer ID used as that identifier. So buildings branch becomes L0 buildings underscore branch. There's its connection string. This connection string, this URL, is just a little bit different than the others because it is a branch versioned feature service. So notice that the name of the version, in this case SDE.default, and the version GUID is included in the connection string. All the others similarly, they have the L, the prefix matching the layer ID, any cleanup as needed to the layer name. And here's the standalone table. Follows the same pattern, the L and then the layer ID, number 3 in this case. One other thing, in the table of contents, I've sort of been adding in layers and then deleting them and adding in a different bunch of layers. You may or may not have noticed that when I add them back, they all come in with the same symbology. And that's kind of a unique aspect of feature service layers. Typically, when you add a layer into the table of contents, it's randomly assigned symbology, matching whatever is its type. But with feature service layers, that default symbology is actually defined on the service. So each time you add them back in, assuming you don't change it, you get the same default symbology. So a unique characteristic, if you will, of feature service layers. Yep, Russell.
Okay, moving into branch versioning. So branch versioning is our new versioning model. It was introduced with Pro 2.1 and Enterprise 10.6. It's purpose-built to support long transactions in services. So it has the same basic workflows that you would have had with traditional versioning, that those same workflows apply to branch. You also have the same types of versions, so you have private, public, protected, and the same sort of rules apply there. It's timestamp based, meaning that you get geodatabase archiving for free. There's no need to enable archiving on your data. Something unique to branch versioning is the ability to resolve conflicts over multiple sessions. You're no longer required to resolve all conflicts immediately after reconcile. Editor tracking supports recording deleted features. This was a heavily requested feature that people wanted to know about their data, and you get that with branch versioning as well. When working with feature services, it's the only way to get undo redo in the Pro application as well. Finally, you don't have to run compress any longer with branch versioning. All of the newer geodatabase datasets will use branch versioning. These dataset types are not compliant or available with traditional versioning. So these new dataset types, I think this will be the 4th time I've mentioned utility networks, parcel fabrics. They're only going to be available through branch, not through traditional versioning. This is only available for services that are published by reference. So if your data is hosted on ArcGIS Online or hosted in your enterprise, it's not going to be available. You can load your data directly through a direct connection to the enterprise geodatabase, but you're not able to edit your data through Pro directly connected to the geodatabase. You need to publish feature services in order to edit the data. Something unique to branch versioning as well is it's a single level of versions. So in the past, you may have had default with multiple children, and those children may have had children, and those children may have had children. With branch versioning, you get default, and then you get one level. And in order to facilitate QA workflows that you may have had in the past, we have a concept of changing version ownership with branch versioning. So when a user is done with their version, they can change ownership to the QA person. The QA person can continue to do the QA and reconcile afterwards. So when we talk about feature services, we can say that they are secured or unsecured. Secured means that it's either not shared at all, or it's shared within specific groups or users within your organization or server. Unsecured just means that you've shared your service with everyone. Anybody can get access to your service. Access to the services is, and therefore the data is based on your portal or server user. So when working with versions, we recommend that you use secured services. You can run into funky behavior if you have an unsecured service and we can't authenticate who you are, and we don't know what permissions you have to create or delete versions or reconcile or that sort of thing. So you can run into strange behavior there. So we do suggest, if you're working with branch versioning, make sure you're securing your service. Another note is editor tracking is based off of the portal user with feature services. So when you do use editor tracking, the portal or server user you're connected as will be the user, unlike with editor tracking in the geodatabase where it's based off the database user. This also means that if you have an unsecured service, you don't necessarily need to provide credentials to connect to it, and you may see like Esri anonymous as the user in your editor tracking with unsecured services. Finally, the last thing I wanted to point out was we do recommend that you make the default version protected to allow for QA to be done before sort of posting all of your edits to your gold standard version. So I just wanted to highlight that here. So to use branch versioning, there's a few steps that you need to go through to prepare your data. You need to create your tables, set up your schema, get your data loaded. You need to make sure that your schema has global IDs and that editor tracking is enabled. OID-based relationships are not supported, so if you have OID-based relationships, you can use our tool, the Migrate Relationship Class tool, to migrate any of those relationships to global ID-based relationships. Regular relationships based off of standard fields that are not based on OID are perfectly fine. So once you've got your data set up, you make a connection to your enterprise geodatabase in Pro. You can go into your geodatabase connection properties, and then there's a radio button to choose whether you want to make a traditional connection or a branch connection. Choose branch. And then, just like with traditional versioning, you register your data as versioned. This time, because you're coming from a branch connection, it will register it as branch versioned. Now it's time to share your map. And so when sharing your map, you need to make sure that you choose the option to reference registered data. Otherwise, you'll be copying your data and you'll be working with hosted services. And then finally, in the configuration of your service, you need to make sure that you enable the version management capability. This, on the back end, will spin up a version management service and will give you the full access to the branch versioning capabilities when accessing these services through Pro. Okay, so this next section is about editing feature services. So permissions are very similar to what you'd see with an enterprise geodatabase. You can have query, insert, update. Note that they're applied to the entire service. You don't have individual permissions on individual layers within your service. So if you need different permissions on different layers, you need to publish different services. Something unique to feature services is it's ownership-based access control. This is row-level security that allows an admin to determine who can view or edit individual rows. So based on the editor tracking fields, we know who created the row, and we can determine whether only the creator can edit, or if other viewers can edit, or if only, for example, the creator can even see that row. Within Pro, this is not something you really need to be concerned about as a developer. It's all implemented server side, but what you may see is that rows created by one user aren't visible to another user, or rows that are visible to one user, when they try to edit it, they may get errors. So let's talk a little bit about the transaction model. There's really two distinct modes of operation when accessing feature services through Pro. We have services that don't have the version management capability, and then we have services that have the version management capability. So services without the version management capability, like I mentioned before, this is going to be all hosted services. You can't enable the version management capability. This also includes any services that you've published by reference that you have not explicitly enabled the version management capability. So this is even if your data is branch version behind the scenes, even if your data is traditional version behind the scenes, if you haven't enabled the version management capability, it's going to behave, the transaction model is going to behave as though there's no VMS. And you're going to get a short transaction behavior. On the other side, we have branch version data with VMS, and that's where you get the long editing transaction semantics in Pro. So you can go through the traditional workflows of creating versions, editing, reconciling, posting, etc. So to help with this, there's a number of pieces of information that you can get about your data using the Pro SDK. So you can ask for the geodatabase type, which will tell you whether or not you're working with a service or a geodatabase. You can get the registration type, which will be non-versioned or versioned. And as I just mentioned, non-versioned is anything that doesn't have a version management service, regardless of the backend data storage. You can also derive the edit operation type, whether it's long or short. So I've built together this little table to kind of help illustrate some of the more low-level editing behaviors associated with individual edits, undo, redo, edit sessions. So the types of versions can be grouped into default when you're editing the default version in Pro, or a named version. A named version is any version that's a child of the default version. With version data against a named version, you get the full editing experience. You can set up events to grab edit events and cancel those before they occur. You can group edits into longer transactions. As far as an example of that would be like something like you move 100 features. All of that one move is all going to be done with a single apply edit. It's called back to the feature service. You also get the ability to undo, redo, and save or discard your edit session. With the default version, the behavior is the same with respect to canceling and grouping edits, but you don't get undo, redo, and you can't save or discard your edits. And then finally, with non-version services, you can still subscribe to edit events to cancel edits, but the other functions, undo, redo, grouping, and saving and discarding, are not available. So the locking model with branch versioning is a single editor, multiple viewer model. The default version has no locking behavior to worry about, so this locking behavior really applies to named versions. This means that multiple viewers can view a version at the same time, but only one user can edit the named version at a time. So connecting to the data store will take a shared lock. Editing will attempt to get an exclusive lock. Saving and discarding edits will release the exclusive lock, and then releasing the data store will release the shared lock. Mixed mode editing is the default behavior in Pro. This is something where you have data from multiple data sources in your contents pane. If you recall with ArcMap, if you had that example and you tried to begin editing in ArcMap, you would have to choose which data store you wanted to edit. With Pro, you don't have to do that, and so we call that mixed mode editing. So for you, you want to be aware that the contents pane may have different data sets with different transaction modes and behavior. So this can lead to unexpected user experiences where you're making edits on something that supports undo, you're making edits on something that doesn't support undo, and then when you try to undo and redo those edits, it's not always clear which one is what your undo is going to apply to. So Charlie's going to give a good demo, and I'll hand it over to him right now.
Okay, thanks, Russell. All right, everyone's favorite topic, editing. So back to Pro. Once again, let's have got a set of demos here we'll work through from left to right. First, let's add in some layers to the table of contents. Nothing special about this code anymore, except here in this particular breakpoint, I'm creating a service connection properties with a URI to a branch feature service. Notice that I'm specifying a version into that .version property. So this is how in the API you connect to a named version on a branch version in Pro. Obviously you do it through the UI on the versioning tab, but if you want to do it in code, you use the service connection properties and the version property on it, specifying the version name you want. And then I'm enumerating through the feature service data store, adding the feature classes as layers, as I've shown before. The only difference here is I'm going to change the named version of the branch version to orange so we can see which features are on that particular named version. And it's those guys here. All right, so before I start with the editing, I want to point out a couple of things. The first thing is on the undo, you'll notice I have some undos, but they're just for all of that adding and deleting layer stuff that I've been doing through the demo. There are no edits there on the undo stack. If I go to the Edit tab, you will notice that the Save and Discard are disabled. The Save and Discard are disabled because we are not in an edit session. They are only enabled when we are in an edit session. Okay, with that in mind, let's do our first edit that I have entitled Edit Direct. Okay, so in Edit Direct, I'm retrieving a mix of layers. One of them is hosted, these two are by reference, and I'm extracting here an individual feature from each. A couple of building footprints, and then this service territory polygon. I'm just going to do a little massaging of those building footprints. And here I'm creating something called an edit operation. I'm not sure who is familiar or not with editing in Pro. It's a coarse-grained API. The edit operation contains a number of different methods for doing things like create, update, delete, in this case move, but there are other things you can do as well. In this particular case, I'm going to move these two building footprints 450 feet to the south. I'm going to take those polygons, those building footprint polygons, I'm just going to use them to cookie cut out basically a donut hole from that territory shape that I extracted previously. I apply that with this modify, and then I execute them all together as a single operation with that edits.execute. I encourage you to go to our advanced editing session tomorrow to learn more about editing in Pro. You notice that those two buildings, they've moved to the south. There's that cookie cut hole that I did in the code. I go to my undo, and there's no undo. I go to the Edit tab, and the Save and Discard are still disabled. So even though I've done edits, I'm not actually in an edit session. I'm not in an edit session because the by reference and the hosted, they are short transactions. They're what we call direct. They're applied directly. So if I want to undo those edits, I actually have to reverse them with another edit. And, luckily that's what I've coded here. Okay, so let's take a look then at editing the default version of branch default. And that's these purple features that I have over here. So in this particular case, I'm just extracting a building footprint. I'm making an edit operation, and I'm performing a move. I'm also moving it about 450 feet to the south. So that building that was there, it's now been moved to the south. I go to my undo stack, and once again, there is no undo. Ditto, if we went to the Edit tab, there's no Edit session. Why? Because editing branch default is also short transaction type. So it is a direct edit. They are not undoable. So if I want to undo it, once again, I have to perform another edit. Okay, let's take a look then at editing the named version on a branch version. That's these orange buildings here. And we're just going to manipulate one of those building footprints. So let's take a look at that. So once again, in this case, I'm getting my branch versioned feature layer. I'm going to move one of those buildings 350 feet north. And that building that was here has now moved up to the north. If I go to my undo stack, I now have an undoable edit. If I go to my edit tab, you notice that save and discard are enabled. So that's a long transaction. I'm now in an edit session. So I get basically all of the characteristics of an edit session, save and discard of edits, and undo and redo. So I can undo that edit. I can redo it, undo, and so forth. Okay, the last concept, let's talk through a little bit in the demo, is something called mixed. So in most cases, I think we kind of know what we have in our TOC, but it is possible, let's say, if we're just developing generic edit tools, where we can have a situation where within our table of contents, we have data that has those different semantic types. In ArcMap, it's not a problem. It's one workspace at a time. But in Pro, Pro actually allows you to have multiple edit sessions all going in conjunction. So in this particular case, I have a file geodatabase with those same buildings called building branch GDB. File geodatabase is long. And then I've got that same service territory by ref that will be short. So let's take a look at edit mixed. Okay, I'm going to get both the layers. I'm going to get a couple of the features from each. I'll do my same move of the building, and then I'll cookie cut out from that service territory shape the building footprint, and I'll do that here with that modify. Okay, building moves, there we've got that service territory polygon likewise edited. I have an undo. The edit shows up in an undo. It is an undoable edit, so I'll just undo it. However, it's not actually quite what I expected. I did undo the edit, but I only undid the undoable edit, the long transaction. So the edit session is just for the file geodatabase. The edit session is not there for that feature service layer. And that's what Russell was talking about in his slide, when you may get unexpected behavior from the undo. So in this particular case, to undo the short transaction, once again, I have to perform another edit to undo it. Okay, so we do have a edit session tomorrow that goes into quite some detail about transactions, mixed, and so forth. So I encourage you to attend it if you want to find out more about that. Russell?
Okay. So moving into our final section, special considerations, also known as tips and tricks. So talking about performance, feature services in Pro can be slower than working directly against a geodatabase in certain cases. We're doing a lot of stuff on the back end to try to make everything work as fast as possible, to try to close any gaps that we might have with file or enterprise geodatabases. If you need to get a count of rows, we suggest using table get count. This uses a much more efficient query on the backend feature service to get the count rather than trying to cursor through all of your rows client side. The get count will work. You can pass in query filters to get information for specific cases. For bulk loading or updating, if possible, we suggest going to the backend geodatabase. If your data is published by reference, if you can append data there, load data there, it's always going to perform better than trying to run the GP tool against the client-side feature class after consuming it through the feature service. For hosted data, we would suggest considering the append and calculate APIs for some of these more bulk type operations where you're calculating a lot of values for a field, or appending data to a hosted service. The backend REST APIs there will work a little bit faster than what we currently have in Pro. Like I said, we're working on that to make that just as fast in Pro, but currently right now, we'd suggest going to those backend APIs. Pagination is something just to be aware of. So I touched on this earlier in the session. We've had cases where people were trying to draw millions of records through a feature service in Pro. That's not gonna work very well when trying to do that, when you're trying to get 1,000 or 2,000 records at a time and you're trying to draw that. So we really suggest thinking about scale suppression and turning layers off at different scales, definition queries if you can limit the number of features being drawn at a given time, that's going to work a lot better. So earlier when I mentioned that cursors are going to appear continuous, if you're cursoring through millions of records, we're just going to keep going. There's nothing that's going to stop you, but we're only going to be able to cursor to make requests 1,000 records or 2,000 records, whatever the max record count on your server is at a time. So that can appear to be really poor performance, but maybe there's a better way to think about that rather than trying to pull everything client side for drawing or certain types of analysis. So some other considerations, if you're looking to do any DDL, so you're looking to modify the schema of your feature services, we have a few things that are available through GP tools and our fields view. Adding and deleting field are supported. Adding and deleting indexes are supported for hosted data. To be honest, we haven't really had a lot of feedback or user requests for more DDL type operations through Pro. So if any of you have things that you'd like to see, please let us know. It hasn't bumped up on our priority list because we haven't really been hearing a lot of requests for it. So rows can disappear when editing. I mentioned one of the very first slides, when you publish your services, you can have a definition query applied to your layer. And if you're making edits that don't satisfy those definition queries, they will appear to poof, disappear. So just be aware of that. If you have some definition query that isn't matched by the edit you make, it's going to disappear. Something that's unique with feature services as well is you can have insert-only services, so services that don't support query. We will allow you to insert features. These are typically used for reporting type scenarios where you want multiple users connecting to a service and reporting information, but you don't want all of those other users to see each other's data. So you can still access those in Pro, but if you're using one of those services, all of your edits are going to disappear as you make them, which can be kind of weird. Both of these cases we've had support requests come in and had to kind of track down and figure out what was going on. So we've been talking all about feature services. You can also, through the same APIs, access map service sublayers. So if you have map services only and you don't have feature services, you can get access to the features of your map services in much the same way that we've been demonstrating today. They're going to be query only. You cannot edit, of course, map services, but if you need query or analysis of your map services, you can also access the feature data in the same ways that we've been showing today. Feature caching, I mentioned this earlier. This is something that's turned on by default in Pro. It's really only going to come into play when you have multiple editor scenarios where the same the same data is being edited in the same area at the same time. In this case, our local feature cache may not show other users' edits on the back end. So for non-version data, you can just refresh the map and that will show the other user's data. If you're editing branch default, you can refresh the version. It will go to the server, check to see if any edits have been made, and if so, it will refresh your local copy. With a name version, it's a single editor model, so there should never be anybody editing the data on the back end behind you. So the local cache should always be up to date. If this is a scenario that you're running into a lot, for non-version data, you can disable the caching through the layer properties in your map. And the feature cache is available for both map and feature service sublayers. Finally, offline feature services, this was a capability that we added at 2.2. You can take your data offline in Pro. Any syncable feature service can go offline. What you need to know is that when it's offline, it's no longer a feature service. It's a mobile geodatabase. And so if you want to access you can still continue to access it through the feature layer, but there's no SDK for the mobile geodatabase as a data store. You can still get to the feature class, though, through the feature layer. Okay, that wraps up this session. Here's a few sessions that are going on the rest of the day. The road ahead is this evening, or this afternoon at 4 p.m. for Pro. Please fill out your surveys. Any comments that you have, we'd really like to hear how we can improve this session. I have this QR code on this last slide. If you're interested in getting the slides, you can use this QR code. It'll take you to a GeoNet PDF of all these slides.